Good morning. I'm calling this video homework help for the substitution rule, which is section 5.5, and the problem set starts on page 381. The assignment, as you may recall, was 1 to 35, the odds, and I suspect that you may have gotten stuck on one or more of them. So what I've done on these opening 3 or 4 screens is I provided for you the substitution, that is what you should take out and put in u in its place. I've taken the derivative du and wrote the differential out, which suggests the substitution for the dx and perhaps whatever is left in many cases. And I'm going to leave each one of these screens up for a bit. You can pause and check your work against mine to make sure that you're using the correct substitutions. And then at the end I'm going to work on the last 4 problems. I think really the last 4 problems are the only ones that present much of a challenge. So the idea here is look at these first 5, 1, 3, 5, 7, and 9. Pause the video, make sure your work corresponds. Then start the video and look at the next screen. And I'm going to take about 5 seconds on each one. You pause as you need to or just move forward. Let's have a look at number 29. And what I've done here in the green is I've gotten you started and giving you a way to think about how you might work with this problem. The original problem was stated as sec cubed x tan x dx, and in my preliminary notes I suggested to you that you break secant cubed into secant squared x tan x. Secant squared x secant x. And I've done that because the derivative of secant is sec tan. So I'm sort of looking ahead and planning and thinking about these pieces and parts. So I'm going to look at secant squared x as a unit, if you will, and let that be u squared, and then everything else that's left, that is the sec x tan x dx, I'm going to allow that to be the du. And the whole idea with all of these problems is to make an easier integral, and I think you would all agree that this integral u squared du is about as basic as they get. So that antiderivative is going to be u cubed over 3 plus c. And then, as you know, the original problem wasn't written in u, so I need to back substitute, if you will. So remember, u is secant. So it's going to be a sec cubed x over 3 plus c, and that's our final answer for number 29. Let's take a look at number 31. Let's talk through number 31 now. And the substitutions I suggested on the previous page would allow us to start putting in first for x. Let's put in what x is, and maybe it was a stretch, maybe not, when I did the original and said, you know, u equaling 2x plus 5 allows us to get x by itself and write an expression in terms of u. And so that's what we're going to put in for x. X is going to be u minus 5 over 2. That next part, the 2x plus 5, that's our u. So let's put that u in place of 2x plus 5, and then raise it to the 8th power, of course. And then our dx, the last of the three factors there, let's take it out and put in its place 1/2 du. So I think you can appreciate the fact that each of those three factors in the integral are now all removed and something equivalent to them is put in their place. Now that first one, u minus 5 over 2, is like a 1/2 out in front of u minus 5, and I have another 1/2 in front of the du. So let's pull those 1/2s out, and 1/2 times 1/2 is a 1/4, and that's how I'm putting the 1/4 out in front of the integral. What will be left behind? Well, a simple u minus 5 will be left in place of the first term. U to the 8th was untouched, and now just du rather than 1/2 du. Now this allows us to multiply through by the u to the 8th and write now 1/4 u to the 9th minus 5 u to the 8th du. So let's take and evaluate that integral, and we've got that 1/4 out front. What will follow will be u to the 10th over 10 minus 5 u to the 9th over 9, and be careful that 1/4 goes with both terms. Now, to finish this problem off, I need to back substitute for u, and u, of course, is 2x plus 5. So let's finish it off. Let's put in 2x plus 5 for u. Let's raise it to the 10th and divide by 4 times 10, or 40. Let's continue with the next term, and won't it be minus 5 times u is 2x plus 5, and let's raise that to the 9th and divide by 9, and then add my c, and that's it, and I'm done. With number 3, I have to use a substitution or an identity for the sign of 2x. So you may recall that the sign of 2x can be written as 2 times the sine of x times the cosine of x. So that's what I'm going to use here to get this thing started. And in fact, I'm going to switch the order up just a little bit. I'm going to write that it's equal to 2 cosine of x times the sine of x. I'm going to put that in place of my numerator, which was sine 2x. Downstairs, of course, I've got 1 plus cosine squared x, and then I have the dx on the end. And I'm doing that because notice that if I let u equal the cosine of x, then the derivative of cosine is negative sine, so negative du becomes a good way of saying or restating the sine of x dx. So now I'm going to perform a substitution. So I'm going to say the integral, and I've got a negative du in place of the sine x dx. So I'm going to put a negative out front, and I'm going to put my negative du in there for the sine of x dx, and then the numerator, won't it simply become 2u over 1 minus u squared? Now, as I continue to examine that, I notice that I could do another round of substitution to solve this problem that I've written in blue here, written in the variable u. So this time I'm going to let v equal 1 minus u squared. And then dv would equal negative 2u du, which would suggest that negative dv is a good way of saying 2u du. So allow me to take my 2u du out and write a negative dv in its place, and the negative dv inserted, if I take the negative out front, now the minus a minus will become a plus. I'll have a plus dv inside, and then all that will be left will be the 1 over, and won't it be 1 over v? So this is an easy integral. This is the natural log of the absolute value of v. So if I back substitute for v, v of course is 1 minus u squared, and I know what u is. It's written in the red, right? U is the cosine of x. So I can back substitute one more time and say we've got here 1 minus u is the same thing as the cosine of x, so it's 1 minus the cosine of squared x plus c. And that's number 33. Number 35 might cause a little bit of problem in that you might not see that there's a common denominator here, and that the integral can actually be simplified or split up into two integrals. And so I've written it out, and again, you may or may not notice that that opening integral, that opening piece or part of it, is easily solved. So this piece, this piece is done. It's completed. So that's already got an answer, the inverse tangent of x. So the only piece that we have to work on is the second term, and that's going to demand a rather simple u substitution, which I've suggested in the red. So continuing with that piece, let's write the integral, and you know, the dx part, in fact the x dx part is half a du. So I'm going to take that x dx out, and in its place write half a du, and I can kick that 1/2 up to the front because it's just a scalar or multiplier. The denominator will become 1 over u now, and now we've got a rather easy integral here. Isn't this the natural log of u? And we can back substitute for u and say u is the same thing as 1 plus x squared. And I dropped out the absolute value signs because they don't really add any meaning now. 1 plus a number squared is always going to be positive, so I don't need that absolute value sign. I could write it now as 1/2 the natural log, and apply that 1/2 as a power and write it as the square root. So what's my final answer up above? Well, that first part that I've got circled, that was an easy one. That's right from the table. That's the inverse tangent of x. The second part, I see a little problem. I took that 1/2 out front and I applied it down below to as a power of 1 plus x squared and wrote it square root of. So I should have eliminated that 1/2 out front. So I've done that now. So now let's write that next term, that evaluation of what I worked on in the blue, and that's the natural log of the square root of 1 plus x squared plus my c, and I'm done. So this is our review of those first problems from page 381, section 5.5, the substitution rule.